Okay, now we will discuss about queues. So in the previous this one, that is sessions, we saw stack and how it will work. Okay, in this session we will see queues. What is queue and how it will store the data and how to insert the data into the queue and how to remove the data from the queue and how to access elements from the queue and all those things we will discuss in this session. So first we will see the definition of the queue. What is queue? A queue is a non-linear linear data structure uh, which follows the FIFO order. That means whatever that element we have inserted first, that will be taken out first. That we call it as FIFO or first in first out order. So it applies with respect to what here insertion and deletion. So here elements are inserted at the rear end and the elements will be removed from the front end. So here it has two ends basically. One is rear end and another one is front end. That means here from the rear end we will enqueue the data, means push the data into the queue, and we will remove the element from the queue, and that process is called dequeue. Here the common operations in queues are these, that is first one is to enqueue, second one is dequeue, third one is peak or front, and is empty and is full. So these are the some common operations that we are going to use in this queue. So here queue can be implemented using arrays as well as linked list in C. So here uh, we can use what here array. In this here now we are going to discuss about how queues will be implemented using arrays. Then we will see the actual scenarios where we are going to use this queue. For example, printer queues. That means the which in to printer which I will give, which page I give to print first, that will be printed first. Then the next, which one I will give as the second, that will be printed next. That is called as what here? FIFO, that is first in, first out. Or you may take the CPU task scheduling. Whatever task you have asked to execute first, that task will be executed first, and then the next task. That means which task has been scheduled next, that will be executed next in the CPU. Okay, and these are some of the different real life applications or scenarios where the queue will be used. It is same like if you go for a movie, and usually nowadays we will not stand in a queue because of the online bookings. But earlier, what used to happen is we have to stand in a queue in front of the theater, and whoever is at the front, he will be given ticket first, next second person, next third person, like that. So first person will be given and the last person will be given ticket last. That is how it used to. So that is also one of the example of what queue. Now we will see here, I told there is a DQ operation and there is NQ operation, and I told NQ operation will take place at the rear end and DQ operation will take place at the front end. Now if I have to push an element or if I have to NQ an element, so this is the rear end. So from this side I will NQ it. Okay. We can also call this rear end as tail or back. So from back side we will NQ an element 9. And if for the same thing, if you see here this side, it is a front end. That means from front end we will DQ an element. That means here element 2 has been DQ'd from the front end. That front end we can also call it as what? Head. So this is the pictorial representation of what here? A Q, where we will do NQ operation and DQ operation. Now we will see the C program to demonstrate how to implement a queue. So first we will write hash include std bool.h, next hash include stdio.h, then hash define max size as 100. So 100 is the maximum size of the queue we are going to set here. That is why I will take max size value as 100. Next we will define the structure of a queue first. So that means how the queue structure should be, that we have to first define it. So first I will type def struct. So this is how we will define the structure. Okay. So type def struct, and this structure, that means this structure has an array called items, which is of size what here? Maximum size. So items of maximum size value is what? 100. So it contains, this items array contains how many elements? Maximum 100 elements. And this array has front and it has rear. And this is what here? Our queue. So this is our queue structure. That means it is array of size what here? 100, and it has front end and it has rear end. So this is how we have defined the structure of the queue now. Now we will see how to initialize the functioning of the queue. So first we will write a function called as initialize queue and q star queue. So that means what here? Here I am just initializing the queue here by taking this q star q. So star q means it will point to the uh, particular location of the queue. Next, this q implies front initially is equals to what? -1. So initially the q front is equals to -1 and q rear will be is equals to what? 0. So these are the two initial values of front and rear of the queue. Now we will check if the queue is empty or not. So for that, as I already told, we will use a function called isEmpty in a queue. So this function is used to what? To check whether a queue is empty or not. So I will write bool isEmpty q star q. Then it will check this condition, that is q implies front is equals to q implies rear -1. That means if the q front is equals to q rear -1 value, then what it will return? That means the queue is empty. That means it has value what here? 0 and -1. Okay. So that is why it will return as it will return, and that means it is empty. Queue is empty. Then we will we'll take another function to check whether the queue is full. So for that I will use the function use is full. So it is of type boolean. That means it will return 0 or 1 value. So that is why we call them as bool. Here also the same. So here bool is full q star q, and it will return if q implies rear is equals to max size -1. max size. That means if the rear is pointing to, or if the rear value is equals to what? Maximum size means Q is, we have elements up to what here? Maximum size of the Q, that is which is the location of the rear node. Okay, right now in index of the rear. That means what here? The Q is full. So this function it will check. Then we will have to write another function where we have to add an element to the queue, and that operation is what? NQ operation. So I will write void NQ. So the value that I want to insert into the queue and at the which location Q star Q. Okay, then first before enqueuing, first I have to check whether is Q, if Q is full. So that is why I will write is Q full of Q. It will print Q is full, otherwise it will return. So if it is full, it will return. Otherwise, what we will do? We will assign the Q at the value at the where we will assign the value at the items of Q implies R. Okay, wherever the Q implies R in the array items, there I will insert this value. So Q implies items of Q implies rear. So at this position the value will be inserted. Then once the value will be inserted at that rear position, then I have to increment the rear. So that is why I will write Q implies rear plus plus. So this is how we will insert an element into the queue. Now we will see the function how to remove an element from the queue, and that function is called as what? DQ function. So void DQ Q star Q. Now first before removing any element from a queue, first we have to check whether the queue is empty. So that is why I will write this function if is empty of Q, that means it will print Q is empty and it will return. Otherwise it will increment what? Front plus plus. So it will increment front plus plus means what here? One element has been removed from the queue. That means if currently if the front is pointing to what? Assume 0, then I will increment front means what? Front plus plus, then front will point to what? 1. That means front is pointing to 1 means what? The element which is at the location 0 has been removed. That is the logic of this line. So this is how we will remove an element from the queue. Now we will use another function called as peek. What is this peek function? This peek function is used to get an element at the front of the queue. That means whatever element which is at the front, that will be that element will be what peek function will get that element. So for that I will write function int peek Q star Q. Again I have to check whether Q is empty. If Q is empty, then it will print Q is empty and return -1. Otherwise what it will return? It will return the front element, that is Q implies items of Q implies front plus 1. So whatever value which is at the front, that value will be returned. Okay, this is what peek function is used. Now we will use another function, that is print q, which is used to print the current q. Okay, whatever elements that are there in the current queue, those elements will be printed. So for that we will write void print queue, q star. First we have to check whether q is empty. So I will write if is empty of q, then it will print q is empty and return. Otherwise it will print current q, and from I equals to q implies front plus 1, because we will start printing from where the front to the rear. So that is why first value I will take it from what here, front plus 1, and I less than q implies rear, because it has to iterate up to where here till it reaches the rear part. Okay, that is why I less than q implies rear. I plus plus, then it will print %d, that is q implies items of I. Okay, I value is what? Front plus 1. Q implies front plus 1, and that items of that value will be printed. Next again I will be incremented by another value, then front will point to the next value, then again it will be printed like that till I is less than q implies rear. It will print all the values that are there in this queue, that is item, then it will come out of this. Okay, after printing all the elements. So this is how we will print the values that are there in the queue. So once I do this, then we have to what? Write a main for this, so that in this main we will actually call a function that is enqueue, dequeue operations, and also to print the elements of a queue. Int mean q, initialize q and q. Okay, I will initialize. So the control goes to the initialize q function and initialize the queue with the values of rear and front. Then we will enqueue elements. Enqueue 10 at the percent q means address of q. So 10 will be inserted, then it will be printed. Next I will enqueue 20, then it will be printed. Then I will enqueue 30, then it will be printed. So like this, these elements will be enqueued and printed continuously. Next, peek front element. So for that we will write a printf statement. Front element is %d peek of and q. So whatever element which is at the front, that will be printed as a front element, that %d, that is that element. Now we'll go for dq and element. Dq of and q, if you write, then the element which is at the rear end will be dequeued from the queue, and then it will print the remaining elements of the queue. So then peek front element of the queue. That means once I dequeue it, then again I want to peek the front element of the queue. Right now the front element is what? Another value, because the previous front element has been removed. Now the current front element will be peaked. That is why we will write printf front element after dq %d slash n p of and q, and then it will return. So the output we will get is what? Current q equals to 10, current q equals to 10, 20, current q equals to 10, 20 and 30. So the front element is what? 10, and again when we write it will print current q equals to what? 30, 20 and 30, because here we have removed what? Here we have removed the front element, that is 10. So the current q is 20 and 30. The front element after dq is what? 20. Okay, because here I am peeking it. once I execute this peak here, so it will print that peak element, okay, which is 20 in this case. So like this we are going to execute the peak and other NQ, DQ operations in the queue. Now we will see different types of queues are there. Okay, here these queues into classified into three different types. The first one is simple queue, which we have seen just now, and there is another type of queue called as double-ended queue, and the third type of queue is called as priority queue. The double-ended queue has again two types, input restricted queue and another one is output restricted queue. The same way here in priority queue also there are two types, one ascending priority queue and another one is a descending priority queue. So these are three different types of queues. So now we will see the simple queue. So the simple queue will follows the what here? The principle that is first in, first out. So as I already said, insertion is allowed only at the rear end and deletion is allowed only at the front end. And it can be implemented using linked list and also a circular array. This queue can be implemented what here? Using linked list as well as using circular array. That means when an array is used, we prefer which queue here? Circular queue, because it is very efficient array implementation for a single queue, simple queue, and also it utilizes memory by reusing the empty space which have been left after deleting an element, and also it avoids wastage that occurs in normal linear array implementation. Okay, in linear array implementation we know that if we delete an element from a particular array, then that will remain not used. But here it is not like that. Here the remaining or empty array can be used. Now double-ended queue, or we can also call it as DQ. D means double, E means ended, QU is Q, double-ended Q. Here in queue insertion and as well as deletion will be performed from both ends. That means in front end you can insert and delete, in rear end also you can insert and delete an element. That is called as a double-ended queue. The third type of queue is called as what? Priority queue. What is priority queue? A queue where each element is assigned with a priority. That is called as a priority queue. That means one element has the highest priority and another element may have the least priority. So depending upon the priority of an element, the elements will be inserted and removed from the priority queue. So here deletion always happens based on priority, not based on the position of the element. Okay, so whatever element if I want to delete, I should first see whether it has the highest priority. If it has the highest priority, we will delete it. Okay, so now we will see different queue operations. So already we saw the different queue operations like NQ, DQ. That means inserting and deleting an element from a queue. Peak we know that it is used to find the front element but without removing it. And then size will return the number of elements in the queue. Is empty will tell whether the queue is empty or not, and is full will tell whether the queue is full or not. Now we will see the applications of a queue. The first application is CPU scheduling. That means here tasks are queued and executed one after another. Okay, that is called as CPU scheduling. They will be assigned, they will be ordered in queue, tasks will be ordered in queue, and they will be executed one after another. The second one is job scheduling. Here printers manage multiple documents in a queue. We can use what here? Multiple documents. That means different documents in a queue. Those will be managed by what here? The printer. That is called a job scheduling. Then we can use the queues for networking also. For example, routers, switches and mail queues which manage the data packets. The next one is buffer management. The queues will act as buffer between slow and fast devices. For example, from keyboard to CPU network devices. So they will work as what here? Buffers also. Now we'll see the advantages of using queue here. The first advantage is efficient task management. Then what is the meaning of this efficient task management? Here this queue will handle multiple tasks or jobs in a fair order. Okay, that means in the it follows the principle of what? First in first out. So that is why each task and job will be handled very efficiently. The second advantage is it supports asynchronous communication. That means here the queue will work as buffer between processes and devices. That means if the process is running in a particular device, then the queue will hold the another process till the current process get its process completed. So that means that is how it work as what here buffer. The third one is it simplifies the resource sharing. That means here the queue is very useful for managing requests to a single resource. For example, whether it may be with printers or whether it may be with respect to CPUs. So if you see this, these requests will be managed. That means if all these requests will be given to a one particular printer or CPU to execute, then the queue will handle the as resources. Okay, so that's how it simplifies the resource sharing also. And also for foundation for exams, algorithms. It is the queue is used to implement breadth first search and also used in scheduling, caching, and other core algorithms. Okay, in different algorithms, it will be used. Next, we will see the queue, as I already told, hash define max 100 int q array, that is max size, that is 100, q of 100, front equals to -1, rear equals to -1 initially, and we will go for enqueuing an element. So I will write void enqueue int element, and then it will check whether rear is full. Okay, how it will check? It will check if rear is equals to maximum size -1, that means it will print q is full, otherwise it will return. Okay, then if front is equals to -1, then it will make front equals to what? 0. That means what here? Front equals to -1 means there was no place to uh, enqueue an element. So that is why it will make front equals to 0 means what? Now you can element is enqueued into the queue. That is the meaning of Next you will increment the rear plus plus. Then you will assign the element where here q of rear. So you will insert where you will insert element at the rear side of the q. So that is why we will write q of rear is equals to element. So this is NQ operation. Now we will see the DQ operation. Here it will check before dequeuing an element. It will check whether front is equals to -1 or front is greater than rear. That means if front is equals to -1 means what? There are no elements in the queue, or if front is greater than rear means what? When front is greater than rear, that means what? The queue is empty, because actually front should be less than rear. Then only that means the queue contains element. But here front is greater than rear means the queue is empty, and it will print what here? -1. Now if the queue is not empty, then we have to remove an element from the queue. So how we will remove an element? Which element will be removed? The front element of the queue will be removed. So we will write queue of front. So that element will be assigned to what? Element. Okay. Then it will increment what? Front plus plus. That means what? This element has been removed. So front, assume if it is at 0 right now before removing, then after removing it, it will become front plus plus means 0 to 1. It will go means what? Right now it is pointing to 1 means what? The element which is at the 0th position has been removed. So it will then return the removed element. So this is how we will dequeue an element from the queue. Now we will write int main nq10, 10 will be inserted, nq20, nq30. So 10, 20, 30 are enqueued into the queue respectively. Then we will dequeue them and print the dequeued value. So print %d dequeue. So which one will be dequeued first? Which has been inserted first? Which has been inserted first? 10. Next we will dequeue 20. Then we will dequeue this 30. So fourth time it goes for dequeuing. So only 3 elements are there. Then it will give an error there. Now we will see how to implement the queue using an array. Okay, so you can see this is an array, and this is here rear end, here this is a front end. From the rear end we will enqueue an element, and from the rear end we will dequeue an element. So the basic operation here is are also enqueue, dequeue, front, rear, is empty, is full, size. These are all the common basic operations of a queue. Now how to implement it using an array? The approach is simple. That is, first we have to define a structure consisting of an array and 2 pointers, front and rear. First we have to define this structure of a queue. Once you define the structure of a queue, then you have to write the maximum size of the array, or initialize the array size, maximum size. Then we have to initialize both front and rear pointers to a what here? -1. So once we do that, then the insertion of elements will take place through what here? Rear pointer, and deletion of elements will take place through what? Front pointer. Then we have to implement is full, is empty, NQ, DQ operations, so that we can manipulate with the elements of the queue. So this is how we have to implement queue. Now we'll see the C program to implement using arrays. Hash include stdio.h, define the maximum size of the queue as what here? 100. Then define the structure of the queue, that is struct queue. So as we already said, it is a the name of the array is queue and it is a maximum size of what? 100, and it has two values to point to the front and rear. So I will declare them int front and int rear. So this is the structure of what here? Queue. Now we have to initialize the queue now. So how to initialize? Void initialize queue struct queue star queue. So q front equals to -1, q rear is equals to -1. That means so initially there are no elements in the queue, so front and rear will point to what here? -1. Now we have to check whether the queue is empty. So for that we will use a function int is empty struct q star q. And if front is equals to -1 means what? Q implies front is equals to -1. The meaning of this is front is pointing toward -1. That means there are no elements in the queue. So it will return this one. Okay, it will return this one. Otherwise, we will use another function to check whether the queue is full. So the function name is full struct q star q. Then it will return, if it is full, what it will return? It will return q implies rear equals to maximum size -1. It will return the rear value which is equals to what here? The maximum -1. It will return. That means if we get that value, it means that the queue is full. Now we will go for inserting an element into the queue by using the enqueue function. So void enqueue struct q star q int data. So this data I want to insert into this queue by using a function enqueue. So before enqueuing it, first I will check whether the queue is full. If the queue is full, it will print queue is full and return. Then it will check if queue is empty. That is, if queue is empty, then it will make q implies front as what? 0 first. That means first front has to point to what? 0th location. Then we will what we will do? We will increment rear so that at that position the element will be enqueued. So that is why I will write q implies rear plus plus. I will increment the value of what? Rear. So initially they were what? For I made them as what? -1. And now it will become -1 plus 1, that is 0. So q implies q implies rear equals to the data. So at that new value of incremented value of rear, the data will be assigned. Then we will print enqueued %d in q, that is what? Data. So this is how we will enqueue an element into the queue. Now we will go for dequeue an element from the queue. So before dequeuing, we have to check whether the queue is empty. So that is why I will write if is empty of queue, then it will print queue is empty and return -1. Otherwise, it will remove an element from the queue. So from where it will remove an element? From the queue of queue front. So array queues, queue is in the form of what? Array. So that is why q implies q implies front, which is at the front. That value will be taken as data. Okay, it will be assigned to data. And if the queue is empty, reset the pointers as q implies front equals to q implies rear. That means q implies front equals to -1 and q implies rear is equals to also -1. Else, then what it will do? Q implies front plus plus, it will increment the front, and element will be deleted from which side? Front side. So it will print deleted element %t data. Which element? Here we have assigned that element to what? Data. So that element will be deleted here and it will return the deleted data. Now we have to display the elements of the queue. For that we will write a function called display. So void display struct q star q. First it will check whether the queue is empty as usual, and then it will print q empty if the queue is empty. Otherwise it will go for printing the elements from the front to up to rear. So that is why initially I will be taken as I equals to q implies front, and up to where it will print up to q's rear end. So that is why I is less than or equals to q implies rear I plus plus. So the first it will print %d, q implies q of I. What is that I? Q implies front. So whatever value that is there at the front, that is the I value. So that will be printed first. Next I will increment it, then next that value will be printed. Next again it will increment, it will print till it reaches the rear end. It will print, and once the I becomes greater than q implies rear, then it will stop printing. This is the display operation of a queue. Now we have to initialize the queue. So struct q initialize the queue and queue. Next we will enqueue an elements into the queue. What are the elements? 1, 2, 3 we are enqueuing. Next after enqueuing we will display them using display function here. Then we will dequeue them. After dequeuing an element, then again we will display the queue. So whatever elements that are there in the queue, those elements will get displayed in the queue. Next we will go for the circular queue. What is circular queue? A circular queue is nothing but again it is a linear data structure in which the last operation will be connected back to the first position. Sorry, last position will be connected back to the first position. That is called as circular queue. Since we connect the last position to the first position, it will form what here? A circle. Okay, it will form a circle. And why it will be used? It will be used because it overcomes the limitation of a normal queue where unused spaces cannot be reused in the normal queues. So here, since we connect it back to the what here, the last to the first, then this rear wraps around to the beginning using again what here? Modulo operation. So this is how we are going to create this circular queue. The key concept in this circular queue are like this. The front which points to the front element, rear points to the last element. And the wraparound condition is what? A rear plus 1% size. This is the wraparound condition. That means it will connect one end to the another end using this rear plus 1% size. You can see here, this is empty space created due to dequeue operation. Since we have done the dequeue operation in the front end, that is 0 and 1, now this has become what here? Empty, waste space. Okay, But here what I will do, I will connect these. Okay, I will connect these. So here -2 is there. Okay, 1 is here and 9 is here. So what I will do now, I have to push the elements from which end. Here in normal case I will push from rear, but rear has reached to its maximum size, so I can't push it here. So but if I connect this rear to the this end, so that means I will push elements from which side? Rear side. So since I connected this to this, that means here, then I push the elements to at 0 and 1 also. So that is why it is a circular queue is. Okay, so now see, I can use these uh, spaces which were empty now by connecting rear back at the front side. Okay, this side. So this is how we will do that. Now we have to implement this circular how to increment this. Okay, here size is equals to what? 5, and here 1 2 3 4 5. Okay, so rear is currently pointing to 4 and front is pointing toward -6, but this is empty. So what I have to do now, I can't push an element from here because rear is also at the maximum position. So from here I can push here, but to push here it has to be a rear end. So that is why what I will do, I will bring this rear, or I will make this rear point to this location. How I will make it? By making rear is equals to rear plus 1% size. That is, rear is equals to rear value is what? 4 plus 1. That means it will become 5. So 5% size is what? Total size 5. So 5% 5 is equals to what? 0. That will become the new rear. So rear is pointing to where now? 0. So now I can push an element from rear, that is 0th location. So that element come and sits in this place. So now now I have used that empty space also. You can see this diagram also, circular linked list representation it is. Okay, data 400 is this one, this address of this node, and it is pointing to this 400. That data is there, and address of the next node, that is this one. So 500 is stored here, it is point to this. Then the data and address of the next node. So the next node is what here? 200. So I will connect this to what? 200, because here 200 is there. So I will connect it back to the head of the node. So this is how we can create a circular link in a linked list representation of a circular queue. Now we'll see the C program for circular queue. So hash include stdio dotted hash define size 5. Now we'll take queue size as 5, because size value is what? 5. So the array which is queue is of size what? 5. Initially front equals to -1 and rear is equals to -1, and then I will execute void function with the value this one, int value. Then it will check whether if rear plus 1% size equals to what? Front. That means what here? Front is queue is full, because rear plus 1 percent size is equals to what here? It is pointing to front. So if it is pointing to front means what? Front will always be which value? The last value. Yes or not? The last value, or sorry, the first value will be at the front only. So if this rear plus 1, that is rear value is what? Minus 1. Minus 1 plus 1 is what? 0. 0% size equals to what? Front. Okay, then that means what? Here it is full. Else I will make front equals to what? Minus 1. Then front is equals to 0 or rear equals to 0 I will make, to make sure that I can insert an element at the rear side. So I will insert this value at a q of rear, that is rear value is what? 0. So q of 0th location I will push this value. Else what I will do, I will push that value at the rear equals to rear plus 1% size. That means I will connect the real new rear will become the this rear, because we already made sure that if the rear side is full, and we have to make the new rear using what here? Circular queue. So to make the new rear to point to the other side, okay, so the formula we are going to use is what? Rear plus 1% size. So that will become the new rear. Then at that new rear position I will insert the value. Okay, so this is how we are going to insert an element. Now we see the display operation. If front is equals to minus 1 means what? Q is empty. Then I will take, if yeah, I will make I is equals to point to what? Front. Why I will make I equals to front? Because the front elements will be displayed first, yes or not? So that is why we will write the front element as I. Print Q elements while 1. And what it will do? It will print percentage Q of I. Okay, whatever value I is there, that Q of I, if it is 1, it will print Q of 1 value. Else if it is 2, it will print Q of 2 value, like that. If I is equals to rear, okay, that means if I value is rear, then what we have to do? We have to break. That means we have to stop. Once it reaches the rear means all elements have been printed, because from front we will start by incrementing it by I plus plus, then we will reach the rear, and when I equals to become rear, that means what? We have to stop the printing. So we will stop it. Then we will make another new I plus 1% size equals to what? I. Then we will stop here. Okay, now we have to write the main, that is NQ of 10, NQ of 20, NQ of 30, where these values will be NQ'd. Then I will display. Then 10, 20, 30 will be printed. Then I will DQ and display. So first element will be removed and remaining two elements will get displayed. Then again I will push 40, 50 and 60, and again I will write display. So now 5 elements will be displayed. Okay, because one element I have already dequeued from it. So these three elements along with earlier two elements will get displayed. So this is how we will do the operation. Now we will see the application of circular queue. It is used in CPU scheduling, memory management, traffic system, and buffers like keyboard and input output. Now we will see the priority queue. A priority queue is special type of queue where each element will be associated with a priority value. Okay. Here the elements will be served on based on their priority value. The higher the priority, they have the they have the chance of getting service. The lower the priority, they have the last chance of getting service. So that is how the priority queue will work. So the values are removed on the basis of priority. The value with the highest priority will be removed first. And again in this priority queue there are types are there. The first one is ascending order priority queue and another one is descending order priority queue. And what is ascending order priority queue? Here in a lower priority number will be given the highest priority. Okay. If the number is 0, that means that element has the highest priority. If the element has value 5, that means it has the lowest priority. Okay. So if you take 1, 2, 3, 4, 5 as priority numbers, 1 has the highest priority and 5 has the lowest priority. This is called ascending order